It's happening. It's happening right in front of our face. So that's not to say that 500 years ago we didn't have 30 hurricanes. So just always an exception to data. So anytime you see data, no matter what you're looking at, know that data is slated for a certain audience. So right about now, every time around this year, you'll see, or I'll see on my Yahoo feed, coffee. Drinking 2 cups of coffee reduces type 2 diabetes by 50%. And I'm like, woohoo, have another cup. But there's a caveat to that. That's set to the coffee drinkers. There's also a lot of disadvantages. There's also some exceptions to that rule, but any data that you see, just understand any data has a certain audience that they're trying to appeal to. So don't just blindly follow any data you see out there in the internet, because there's a lot of rubbish out there. My friends will bring up data all the time on any subject. And first question, where did you get it? Facebook. We're done talking. Go away. This isn't even an intelligent conversation. So just know who the audience is set for, and know who is sending out that data. There's a lot of reputable sources, but even a reputable source is going to have an audience that they're trying to appeal to. Doesn't mean the data is wrong. It could be 100% correct, but there might be other data that goes with it that can show the other side. And just a good, the more you know, public service announcement. So the atmosphere. The atmosphere is something that we are experiencing every day. So the very first day of school, we talked about the spheres of the earth. We talked about the geosphere. We just got done talking for 9 weeks about the geosphere, maybe 12 weeks, from rocks to minerals to earthquakes, volcanoes, plate tectonics, maps, all that is geosphere. Hydrospheres, all the water of the earth. Biospheres, all the living things in the earth. That's what you'll do in biology. The last of the spheres is the atmosphere. So the atmosphere is that big old blanket of gases that keep us safe, that insulate us when it gets cold out, that shield us whenever we're getting full radiation. Our atmosphere does a really, really good job at keeping us at the Goldilocks temperature, not too hot, not too cold. And the fluctuations take a very, very long time to happen. So who studies the atmospheric conditions? Again, it was a branch of the earth science. We talked about day one, and that's meteorology. So, excuse me, a meteorologist is somebody that studies the weather patterns, the atmospheric conditions. Meteorology is the study of the atmospheric conditions. Old picture, George Hirschman has since retired. I think the other two might be there. I don't watch Channel 3 News, but meteorology. It used to be a guessing game. It still is a guessing game. We have a little bit better capabilities of predicting the weather. 72 hours, where we can be really, really accurate. So when you see a 24 to 72 hour forecast and it says it's going to rain 80%, you better take an umbrella. That's a really good indicator. But the industry has blown this up, so we get on our apps more often. The Weather Channel is super guilty. Now they extend their forecast from 5 days to it was 10 days. Now it's 14 days. They don't know what's happening in 14 days. They don't have a clue. But in the wintertime, I guarantee you the last 6 days of any 14-day forecast is going to have snow flurries. Every time. I guarantee it. Because what do people do? Oh, well, let me check. It's been a couple of days, or it's been a day. Let me see if they changed that. And they'll make it go away. Then they'll make it come back. It's just ad space. It's kind of a little bit of rubbish. Anything beyond 3 or 4 days, we really just get into the guess. But we're getting better with our short term. We're trying to predict hurricanes, doing that a lot better. Tornadoes, we're still researching on tornadoes, on figuring out where they come from and how they form and where they're going to form in the ideal conditions, because we still don't know that when it comes to tornadoes. So when we talk about characteristic of the atmosphere, I'm not sure why there's a big old space there, but we're talking about what the atmosphere is made up of. And before we even talk about that, we're going to talk about the two, either weather or climate. So these are two terms you're going to see that coincide, a perfect Venn diagram type thing, weather on one side, climate on the other. So weather is what's going on right now at a particular place. So right now, our weather is partly cloudy. I don't know, it's probably 60-some degrees, 65 degrees out there. That's what our weather, that's not our climate. Your climate is your tropics, your tundras, it describes your biosphere, it describes what's going on in a grand scheme. Arctic climate, very, very cold. So I think of weather and climate like this. If I'm going to go to vacation in Yellowstone this fall, like now, I want to look at the weather out there and see what's the weather. It might be snow and 15 degrees. I want to know that. But if I'm going to move out there, I want to see what the climate is. What's the big picture? What's their yearly big picture? So Pennsylvania, our climate in Pennsylvania, our winters last about 4.5 to 5 months. So you have November, December, January, February, March. So you have about 5 months of winter. Here in Virginia, our winters really don't start until the end of January or the end of December, January, February. And in getting into March, we might get those storms, but the apple blossoms are popping out. So we have about 3 months. So there's a big difference. If I'm going to move somewhere and I hate the winter, 5 months of winter is a lot of winter. So Pennsylvania, northern New York, Maine, New England states, or Michigan, those might not be where you want to live. So again, you might go in the summer and say, oh, Pennsylvania is awesome. The weather out there that particular time was awesome, but the climate is lousy. I love Virginia. Virginia, we've got such great, this is just so nice. We have a little bit of weather, a little bit of winter. We have a nice summer. The fall is beautiful. Spring happens quick. It's nice. I'll take Virginia. Okay, so when we talk about the composition, that is the ingredients of the atmosphere. So what is the air you are breathing? Every breath you take, what is in that air? So throw it in the chat. What's every breath you take? What's the number one gas that you breathe in? Oh, Alex. Oh, go back. Oh, and if you have the, yeah, I guess that's kind of a thing. But that was my tribute to Alex Trebek. Oxygen. Oxygen is absolutely one of the most essential gas out there. Absolutely. But it's not the number one. So if you look at this pie chart, the highest percentage of gas is nitrogen. Oxygen is only 21%. Nitrogen is 78%. That's interesting because if we had 21% oxygen in my classroom, if I filled my classroom with 21% oxygen and I filled it up with 78% of pretty much any other gas, I would be dead. If I filled it up with 70% carbon dioxide, if I filled it up with 70% hydrogen, helium, I would not survive. Nitrogen is such a great gas because it's a, there's a term for it, innocuous. It doesn't harm us or help us. It's just a perfect placeholder. We can breathe it in and breathe it out. It doesn't affect us in any way. But if it was mostly any other gas, we would not survive in that environment. So 78% nitrogen, 21% oxygen, that leaves about 1%. And we're going to have a 0.9% argon, and everything else is going to be in that 0.1%. So that is your hydrogen, your carbon dioxide, your carbon monoxide, that sort of thing. Okay, great question. If it's 99% oxygen, you will not survive. You need to have at least around 16 to 18% oxygen to survive. It's called IDLH, immediate death and life hazard environment. So if you may have done this by accident, or like it's cold out, so you drive a car into, or you're with somebody that drives a car into a garage, and you're talking a little bit, and you shut the garage door, and then you shut the car off. You're filling that garage up with carbon monoxide, and that's just that can't. You need to have that 16 to 21% environment. It is getting wintertime, so carbon monoxide detectors are key. This is a time of year where you're firing up your furnace for the first time. I am not very good with keeping up on my appliances. I don't know there's a problem until I turn it on. So you fire up your furnace, especially if it's a natural gas furnace or something like that, and the vents are clogged, the filters are clogged. so that vent isn't going up the chimney, it's coming in, then you have likelihood of getting inundated with carbon monoxide or carbon dioxide, a CO2 alarm, carbon dioxide alarm. That's why you have them. They're like smoke detectors, but they're for carbon dioxide, and they're very important. They save a lot of lives. So that's just something that you want to make sure. We want to make sure we have smoke detectors at work. You want to make sure that you have a decent furnace, and a nice way to check that is to have a carbon dioxide alarm, because if they beep, then you need to go out. And you might get headaches if it's just a little bit of carbon dioxide. You'll get a headache, but then you'll get nauseous, and then if you think it's just the flu or something and you go to bed, you could get really, really sick, or you could die. Carbon dioxide poisoning, it happens every year. So that's just something to not scare you, just to make you aware. Argon and 0.1% of the other stuff is what brings this to 100%. But good question. You've got to have that 16% oxygen. So with composition, and you don't even need to write this goes under composition because it's a letter one or a number one. But we also have a thing in our upper atmosphere and lower. When it's in the lower atmosphere, it's not good. But in the upper atmosphere, it's a wonderful thing called ozone. It's 3 oxygens bound together, and what it does is it shields us from the UV rays, the ultraviolet rays from the sun. So when the sun sends us UV rays, this ozone layer is protecting us. If it wasn't there, then we would be getting a lot more solar radiation, which would change the Earth. If you had more solar radiation, a lot of things are going to happen. And we have a hole in our ozone layer. You undoubtedly know about this. There is a hole over Antarctica. So the next bullet says damage by CFCs. Well, CFCs and poisons like Freon that are in air conditionings and refrigerators, CFCs are in the 80s and 90s, well, in 60s, but 80s and 90s, big hair. If your parents were in high school in the 90s, your moms had big hairs. That was always who can have the highest hair. And they would like, I would fluff mine up and hairspray it all up. I used my hairspray this morning, but they would use a lot of hairspray. Cans and cans of it. Well, what hairspray basically is it's a glue, literally a glue in liquid form, and they put it in a metal container. This is not an aerosol container. Pretend this doesn't have this type of lid. And then that last little bit of space, they've put CFCs, chlorofluorocarbons, in it. And what those CFCs do is it pressurizes my container. So when I hit the top, right in my eye, turn it, make sure it's, then I can use it to, get my dew on. What those CFCs do, though, is after this hairspray goes on your hair, they're very, very light, and they float. They float the whole way up into the upper levels of the atmosphere. And what they do is they attack these ozones. They don't really attack them. They just go up and hook to them, and they disconnect them. They separate those 3 oxygens. So now you just have oxygen, and they deplete the ozone. Together, 3 oxygens, strong, save us. Separate, it's just another molecule in the atmosphere that really doesn't do anything but keeps us alive. And no one's living up in the stratosphere. So CFCs were bad. They started to form a hole in Antarctica. And the whole world got together. The whole world, it can't agree on anything like world peace and hunger and all that stuff. We can't agree on that and help the world out. But we decided that CFCs were bad. And they basically banned them from the world. Now they use different gases like propane and methane, and not the best, but that dissipate, and they don't necessarily go up to harm the atmosphere, the ozone layer. So my question is, that's a great question. So someone asked, why is the hole over Antarctica where nobody lives there? It's not because people live there is why there's a problem. Canada has some of the worst air pollution in. At one point, they had the worst air pollution in North America, and South America, but they didn't have a lot of industries because it was Detroit's pollution that was going up there. So with the spinning of the Earth, and it's a light gas, it accumulates for whatever reason down south in the upper atmosphere, but at the South Pole. That's a good question, Alex. And I'll find out more details in that if it has some kind of magnetic attraction or whatnot. But that's where it accumulates. It's everywhere, but it accumulates at the North Pole, and that's why the hole is there. And now, if you imagine you have a gigantic hole over Antarctica, well, what's the weather going to start doing if there's no ozone layer? Is the temperature going to increase or decrease? Yeah, it's going to get warmer. And when it gets warmer, it's going to melt. And if you have ice and snow that melts, then when the sun hits those big chunks of ocean, we're talking thousands of square kilometers of ice that's melting every year. But when it's ice, the energy from the sun hits it and bing, bounces away. But now that it's not ice, the sun's energy hits it and absorbs by the water. So now our oceans are getting warmer. They're getting fresher. There's not as much salt because the ice is fresh water and ice doesn't have salt in it. So we are just throwing all kind of monkey wrenches into our oceans, and all of our climate and weather is driven mostly by the oceans. And now when you do that, your oceans get warmer, and then voila, before you know it, it's November 10th, and we have another hurricane in the middle of the Atlantic that has to have warm oceans. So it just kind of goes to show that that this is all a process, and it's all connected. One little thing happens, and it is a snowball, no pun intended with Antarctica. It's snowball effect. So we are fixing the hole. That's the good news. So we got rid of all CFCs. The hole is slowly closing. It might take hundreds of years, but as long as it's not getting any bigger and it's slowly starting to close, that's a win for humans. Yay, humans. Okay, so a bunch of cycles, and we'll talk about the water cycle. You have the nitrogen cycle, the carbon dioxide cycle, the phosphorus cycle, the sulfur cycle, the rock cycle. So rocks can go from any rock and back again. Well, the oxygen cycle basically said it's a cycle of oxygen. Plants are using carbon dioxide, so they kind of go hand in hand. Plants are using carbon dioxide to add that with solar energy, and they use those two things to create glucose. It's amazing. They feed themselves with the sun. Imagine not having to eat. You're hungry, you just go outside in the sun. And when it's cloudy, you're like, oh my gosh, I'm so hungry. But that's what's happening here. And that's a great thing because it's bringing in and using a pretty large amount of carbon dioxide. Animals breathe in oxygen and they breathe out carbon dioxide. And finally, the burning of fossil fuels. That's another way we add all of this carbon dioxide to the environment. And that's what we're doing. That's one of the ways that we're kind of screwing up our environment, because we have electricity. We use more and more electricity every year. Well, where does electricity come from? Power plants. And most 80% of power plants get their electricity or get the energy to make electricity from burning coal. Coal is a fossil fuel, creates a tremendous amount of carbon dioxide. Wood burners. My wood burner at the house, I create a fairly decent amount of carbon dioxide. It's not as bad because it's not a fossil. So when I cut a tree down, that carbon is like, it's not a storage of carbon. So it's not as bad, believe it or not. Our cars are horrible because we get our car fuel from gasoline, unless it's a hybrid. And where gasoline comes from oil, and oil comes from dead sea critters that have been buried for millions of years. And when they're buried, all of that carbon is in the ground, and it's safe and it's secure and it's not getting out, and it could stay there forever. But when we burn it, we're releasing all that carbon into the air extra. And that's why that's bad. Again, climate gets warmer, and you might have heard a thing called permafrost. It's up north where it's frozen year round, and that ground is frozen, but in that ground is thousands of years, hundreds of thousands, if not millions of years of plant decay, animal decay, biotic decay, organisms that aren't completely decayed out. And they're just fossilized, basically. And when it gets warmer, they open up. And when they open up and get exposed to warm climates, they decay. And when the decaying process continues and finishes, it's releasing all kind of carbon into the air. Again, another bad thing. Every little thing is going to have a play and going to going to equal something bigger. Whew. Sorry, I kind of went off on a tangent there. If that you like that kind of stuff, I teach AP Environmental. We really dive into it a little bit more detailed. So this is a thing, again, you've heard of, a greenhouse effect. The important thing to learn here and to realize here, and that's right here, that it's natural. Oh, of course, I picked the dark. This is a natural process. This happens without humans. So if we went back pre-humans, this would still happen. It's natural. You get volcanoes, you get more debris, you get more gases, and the Earth's temperature is going to increase and then decrease and then increase and decrease. That's a fact. What also is a fact is we're adding a lot more carbon and a lot more greenhouse gases like methane into the atmosphere. So we're speeding up this natural process. But what it is, and you've all experienced this, let's say it's almost Christmas and I want to go Christmas shopping, and let's say there's no pandemic. So I'm going to go to this. I heard Stanton has this awesome shopping mall. I mean, it's fantastic. So it's a really cold December day, like 10 degrees. And I go to the parking lot at the Stanton Mall. I find a spot because you cannot find a spot to park in the Stanton Mall because it's such an awesome mall. So I park at the mall and I go in and spend hours in the mall just shopping away. And when I come out, I'm thinking, oh my gosh, it's 10 degrees. It's going to be freezing cold in my car. So I run to my car. I get in to start it up. And I don't have to hurry because it's nice and warm in there. And the reason why it's nice and warm in there is because I have windows. And the sun's energy is coming in those windows and being absorbed by the seats and the floor and the carpet and the ceiling. And then that energy is bouncing, but the windows are keeping it from all escaping. So it's just bouncing around in there, just being absorbed. And that's why your car is so warm. They don't call it the car effect. They call it the greenhouse effect because that's exactly what happens to a greenhouse. Full glass, the light comes in, all the plants and soil absorb that energy, and it gets much warmer than it is outside. I mean, if you've ever been to a greenhouse in the middle of winter, it's very, very warm and humid, even in the middle of winter, because all that water vapor is there. All the glass is keeping the soil or keeping the energy there. Now, if you come back at 2 in the morning, you're gonna freeze because there's no light. Glass doesn't hold the heat in, so it's gone. So you have to have heaters at night. But I digress. Certain gases absorb sun's energy better than others, and those gases are greenhouse gases. Include carbon dioxide. We get that from breathing, but mostly from burning of fossil fuels. Methane, cow farts, lots and lots of cow farts in the world. So much that it's a problem. I mean, that's a lot of cows, but you figure we have these industrial feeding operations that have thousands of cows, and those cows are eating and drinking water and pooping and farting. Eating and drinking and pooping and farting. It's a good song. I need to. And sorry, I used to sing it to my kids all the time. So that's a remix. But anyhow, that's what's going on. So we have enough cows that we're actually changing the Earth's climate because every burger you eat, you are, that cow drank so much water. I think one burger is 6 bathtubs of water. 60 bathtubs of water. It's 60 bathtubs. It's a crazy number. It is. They use so much resources. But don't get me wrong. I might go home and get a burger when I go home. So I'm not being hypocritical in saying don't eat burgers because I love beef. But anyhow, to the point where some of these farms, these feeding operations that have actual barns and are not outside all the time, they collect that methane. They actually have vacuums in the ceilings, and all the methane goes up, and the vacuums suck it all out and put it in tanks, and we can burn it for fuel. If you ever go near the landfill, there off of Greenville exit on 81 behind Stewart's Draft, there's a big landfill. You'll always see a flame, blue flames all over the place because garbage decomposes. When it decomposes, it releases methane. And instead of letting that methane go up into the air, it's less harmful if we burn it. And we don't want it to settle and explode. So we let it burn. And we actually light the fire, and it just burns 24 hours, 7 days a week, 365 days a year. Always burning. Okay, so methane. Water vapor. Water vapor is harmless, but it's also a greenhouse gas. Okay, so this takes us to layers of the atmosphere. I want to blast through these. Tomorrow, incidentally, we'll have a demonstration and an activity, so you probably won't take any notes unless we don't get finished with the layers of the atmosphere. So, and I might actually flip, I might start flipping some lessons. So I might start having these recordings and having them on my website, and you still need to take notes on them and fill in slides, but it might help us out because of the time issues that we are facing. And that way you get grades for it still, and you can still learn the material. So layers of the atmosphere. From the ground to the space, there's not just one layer, there's multiple layers. And how we know we're going from one layer to the next is because the temperature is going to change. It's either going to get warmer or it's going to get cooler. So that's how we know we're leaving one layer and we're heading into another, is because whatever layer we're leaving, the next one is going to be the opposite. So if we're leaving a layer that's cooling, the one that we enter next is going to be warming. And then the one layer next, the one layer we enter next is going to be cooling. So cooling, warming. So remember, it starts with cooling, and then it just goes every other one from there on up. So when we break it down and we talk about the layers, our first layer is the, need me to go back? Our first layer is the bottom layer. It's the layer we live in. It's the troposphere. So the troposphere is the bottom layer. We live here. All the weather occurs here. So if we ever, like this picture here of this thunderstorm, it's not the best picture. So let's make it a little more realistic. So you have this cloud going up, and it's actually gonna like go way out there, and it's gonna go way out here. And the reason why it moves out this way, because it can't go up. It can't go up anymore. This is basically a shelf or a lid. This is the stratosphere. We're in the troposphere. So where they meet is a layer that you can't have air going any farther up. And that's why you get these big mushroom cloud storms, or they call a cumulonimbus cloud an anvil, because it looks like an anvil, it pops out. And that's what's going on here. So all the weather occurs in the troposphere. So if you're ever flying an airplane and you're in a big jet, like a 747, and you might hear the pilot, and since I have this on, I can pretend I'm a pilot. Ladies and gentlemen, may I have your attention, please? This is the pilot speaking. And they talk like that really soft and really fast because they don't want you to hear what they're going to say. We're going to crash and die. And you'll be like, what did he say? No, but he might say, hey, we got some thunderstorms ahead, so we're going to go up. We're going to go up and around so we don't have to go through them. And they can go higher. They go up if it's a big enough plane and it's a plane that's safe enough to go at that lower level of the stratosphere, they will go up and fly over top of these storms. I was flying home from Utah, and we're flying from Montana, but we had to go to Utah. Anyway, on the way home, we went right through, I swear the pilot purposely went through every thunderstorm that there was in the continental United States. I think we zigzagged. And it was, it shook, and it was not fun. I don't like to fly, and that did not help me at all. And the flight out was terrible. I don't like to fly. I'll drive. Thank you very much. But it's the bottom layer. We live here. This is important. The last one that I should have clicked like 20 minutes ago. As you go up, temperature goes down. But Mr. Twerdy, you're getting closer to the sun. That is a fantastic question and observation. Yes, as you go up, you are getting closer to the sun. But the sun is something like 93 trillion miles away. And as you go up Mount Everest, you're going up 29,000 feet. 29,000 feet versus 93 trillion miles isn't even a grain of salt on a beach. So you're not getting any extra energy from going up in the atmosphere. But what you are doing is, let's say this is not a coffee cup. Let's say this is a light bulb, and I turn it on, and I leave it on for a couple minutes, and then I touch it with my face. Ouch! It burned me. Don't touch a light bulb with your face, people. The more you know. But if I touch it, then it is going to be hot. But if I go way up here, it's not going to be hot. I'm not even going to feel it, because as this heat rises, it's going to cool. And by the time I get a couple, maybe a foot and a half away, there's no energy. Well, the earth is the same way. The earth is the light bulb. So don't stick your face on it. Actually, you'll be all right, unless it's like a blacktop. So the earth is the energy. It's the light bulb. It's where all the heat is. And as you go further away from the earth, it gets colder. And that's why it's so cold on top of the mountain. And the air gets thinner. And the thinner air, the less molecules there are to absorb energy. We'll talk about that tomorrow, because we're not going to get done with these. We'll have a little bit of notes tomorrow, because we've got to at least get through this. Last slide for the day is the stratosphere. Strata means layer. So a stratovolcano is a volcano that has, gosh, you guys are on fire. Different layers. Fantastic. Also known as a composite volcano. So a stratosphere, in the stratosphere, the most unique thing is a triple bond of oxygens, 3 oxygens. 3 oxygens make up, boom, ozone. So ozone layer is in the stratosphere. So if the troposphere gets cold, what does the stratosphere get? Warm. You are absolutely correct. It gets warmer. And the reason why it gets warmer is because those ozone layers are absorbing UV rays. If I have a bulletproof vest on and somebody shoots me, and first thing I'm going to do is check to make sure that it doesn't go through, that it didn't go through. That would be bad. But I'm also going to want to give some space or take that vest off, because it is going to be very, very hot. Not only am I going to have potentially broken ribs, be traumatized because I just got shot, but luckily this little piece of man-made object saved me. I could get burned, because when you take all that energy from a bullet and you stop it like that, it's going to release that energy, and that energy is going to get absorbed through the bulletproof vest, and it's going to create a lot of heat there. And that heat can potentially burn you. It burns us. A little Gollum action there. No? Lord of the Rings? Nobody? Nobody? I knew you would get it. Okay, so last but not least, because of this absorption, the temperature is going to increase. It's going to go up. And side note, I had an extra cup of coffee today, and I think that's what's wrong. I think that's why I'm so, but it's a good day. It's just been a good couple of days. So that's that. That's the stratosphere. That takes us to 12:13. That's a good place to stop. Tomorrow we will pick up on